Hello again. This video here, as the title suggests, will concern itself with the inverse trig functions. And we left off class today, we ended class today with this statement up on the board. When you see something like sine inverse of 1/2, that means the angle between negative pi over 2 and pi over 2 that has a sine value of 1/2. Essentially, we're looking for the angle that has a sine of 1/2. That's what this statement means. I put this between negative pi over 2 and pi over 2 here because that is the range of inverse sine. If this was a cosine inverse problem, this would be slightly different. It would be between 0 and pi because 0 to pi is the range of the inverse cosine function. Let's take a look at this. Where would this be on the unit circle? So here's a little unit circle, and sine value of 1/2, okay, well that's right about here. First off, the angle between negative pi over 2 and pi over 2, so that's kind of like around between there and there, all right? So if it has a sine value of 1/2, then it is approximately right about there. So that actually, and you can remember this from your unit circle expertise, that is pi over 6. Okay, and it's important to realize that it is only pi over 6, because that's the only angle between negative pi over 2 and pi over 2. There is another angle over here, 5 pi over 6, that has a sine of 1/2, but that is not in between negative pi over 2 and pi over 2, so we don't use that one. So let's take a look at another example here to kind of get this idea in our head a little bit better. Here's another expression, cosine inverse of negative root 3 over 2. Well, if you remember, the range of the inverse cosine function is between 0 and pi. So in this case, we are looking for an angle between 0 and pi that has a cosine of negative root 3 over 2. If I kind of sketch in my unit circle values there, it's not quite a circle, but you get the idea. Negative root 3 over 2, okay, that's going to be somewhere right around there. So our angle is right over here. And if you recall, that's going to put it at 5 pi over 6. So the one and only answer for this, or the only angle that this expression right here means, is 5 pi over 6. There is another angle down here that has the same cosine of negative root 3 over 2, but we don't use that one because it's out of the range of inverse cosine. So in the rest of this little video here, we're going to talk about something that concerns many of the problems in this assignment, and that is when we are composing inverse trig functions together. So the composition of inverse trig functions and just the regular trig functions is what this is about. So to begin this, remember that back when we were studying functions, and inverse functions in particular, that when you compose a function and its inverse together, the output of that is the same as the input. In other words, f of inverse f of x is equal to x as long as, and here's the little caveat with that, that is true as long as x is in the domain of inverse f. Normally, that's not really such a big deal. It's kind of one of those little legalese, little math phrases that kind of is tagged along with a rule that doesn't seem to really affect anything. Because for most of the functions that we study, the domain is all real numbers, and we don't really have to worry about that so much. Of course, rational functions, square root functions, things like that have their restricted domains, and so sometimes it does become an issue. And in this case, with inverse trig functions having severely restricted domains and ranges, this becomes now kind of an important issue. So let me explain a little bit what I mean by this function composition thing with inverses. Here's something I just, over here, I just took this little picture out of the textbook. There's a statement like this for all three of those inverse trig functions, And pay attention to what this means. You'll see some problems like this one right here. All right? And your job in this problem here is to figure out what this equals. Okay, so the cosine of the inverse cosine of 2/3. So cosine and inverse cosine are inverse functions, and the input, which in this example over here you see as x, is the same as the output as long as that x is in between, is in this domain here. This is the domain of the inverse cosine function from -1 to 1. So as long as that's true, then this is equal to itself. So there you go. 2/3 is in this domain, so this just equals 2/3. Easy as that. When you reverse them, okay, cosine inverse of cosine of pi over 2. When you look at that, okay, look at this over here. That's this situation here. Cosine inverse of cosine x equals x as long as x is between 0 and pi. Pi over 2 is between 0 and pi, so this just equals pi over 2. Okay? Let's take a look at this one down here. This one, let's see, we've got this expression right here, cosine of inverse cosine of -3. All right, that's this one right here, isn't it? Cosine of inverse cosine of -3, that should equal -3 as long as -3 is between pi... Oops, wait a minute. -3 is not in between -1 and 1, so this, in fact, is undefined. Okay, you could say it's nothing. It's undefined. All right, and that's how we deal with that. So when you're working through these problems, take heart into the fact that many of them will be the easiest possible answer. A few of them will be undefined, and they will actually throw a curveball at you once or twice. So make sure that you check your solutions with your results. Okay, let's take a look at another example of this, because they don't always just compose a function with its inverse. For example, some of the problems are like this: the cosine of inverse sine of √3/2. Well, we're no longer composing a function with its inverse anymore, so that rule that we were just talking about does not apply. But here's where I want you to go back to what is the meaning of this statement right here, inverse sine of √3/2. That means, once again, the angle that has a sine of √3/2. Okay, so think about your unit circle now. Think about the sine, and it's got to be over here, somewhere over here. An angle that has a sine of √3/2, that's up here, and yes, that would be pi over 3. Pi over 3 has a sine equal to √3/2. So a way to kind of deal with this problem is we are actually talking about the cosine of pi over 3. All right? Because sine inverse of √3/2 equals pi over 3. So this is the cosine of pi over 3. And we know what that is. That equals 1/2. So there is more to come about this topic. This will not be the end of our little videos or discussion about this, but that should get you through this first chunk of homework problems. Okay, take care, and feel free to replay or stop or repeat any part of this video. Okay, see you later.